Hello guys, this is the first video in a many-part series explaining the basics of CAD. For those of you who do not know what CAD is, it is computer-aided design and allows you to build the robot virtually first, test fit components, and then be able to build the robot quickly. The program I'll be showing you is Fusion 360. There are other programs such as Autodesk Inventor and SolidWorks, but Fusion is great for beginners as it is very simple. Now, if you go to Autodesk and try and get Fusion 360, you'll see that it costs money. However, Autodesk has a student copy of basically every software Autodesk has, and that link to get the student version of Fusion will be in the link in the description. So to start off, I'm currently using a library that a bunch of creators made, and you can download this one library instead of going to VEX's website and downloading every part individually. This library will also be linked in the description as well. So when you have downloaded Fusion 360, the first step is to create a master folder, perhaps named Robotics. In that folder, you can then upload the downloaded library. What I do, because I like to stay organized, is create another folder inside the Robotics folder named Changeup. Then in there, you can save your file there and name it whatever you want. Just a note, I will be demonstrating the CAD of a tower takeover robot, which we would have taken to the Create US Open last year. The great thing about the library is that everything is already divided up into folders such as electronics and aluminum. When CADing a robot, I recommend having some type of drawing or specification sheet for the robot, which includes dimensions so you know how big the robot should be. Also, be sure to start off with the base as that is the foundation on which your robot will be built upon. Remember, each hole in a C-channel is a ½ inch. I start out with 4 35-hole C-channels, which is 17.5 inches to build the C-channels surrounding the wheels. As you can see, I rotate the C-channels in a way that the flat sides are on the inside. This is because in my final version of the robot, I want the flat sides to be in the middle so it is easier to build. I orientate the C-channels this way so it is easier to move on. Here, you can create a component under the assembly structure section in the toolbar. This way, you can keep all of your components in the tree very organized. I like to make one named base metal. I then want a 27-hole C-channel going across as I want that to be the width of the base. However, you may see that the library has no 27-hole C-channels, so you would have to cut it virtually. Many people have different ways to cut their C-channels, but the way that my team and I do it is by activating the component we want to edit. That way, any cuts that we make are only on the component and not on any others. To activate the component, hover over the piece in your tree and click the circle on the right-hand side of the component so there's now a black circle filling the circle. You should now see that the original 4 C-channels you brought in to be ghosted. Now you want to hit Create Sketch on the toolbar on the top of your screen, and when you hit Create Sketch, click the flat side of the C-channel you want to edit. Your screen should then automatically move to show the flat side zoomed in. Because I want a 27-hole C-channel, I want to cut off 8 holes from either side of the C-channel. Once you're zoomed in on the channel, you want to select the rectangle as it is the easiest way to cut a C-channel. You can see I do not line it up in the exact center. That's because I do not have to. I can edit where the C-channel goes in a minute. The important thing to remember is that the rectangle you make should be larger than the C-channel piece you're trying to cut. I then take the measuring tool in the inspect part of the toolbar and click on the edge of the rectangle and the edge of the hole of the C-channel like so. Fusion automatically puts everything in millimeters, and I found that 4.0385 millimeters to be the exact center of the edge of the holes, so I just type 4.0385 in and hit enter. Now, the rectangle edge will cut right in the middle of the C-channels and will give you a perfect cut. You can now hit Finish Sketch, which is the green check mark in the upper right-hand corner. At this moment, you might have realized that I put the rectangle on the wrong side of the C-channel. Instead of cutting 8 holes off, I'm cutting 27. This is not a problem though. Just make a new sketch or you can just edit the previous one. However, before you delete the wrong rectangle, make a new rectangle in the correct area this time. You can start at the bottom left corner of the original rectangle you made, as you know that is already the middle of the holes. Then just drag the rectangle so it covers the 8 holes and drag towards the upper left-hand corner. Then just hit Finish Sketch. Now, how do I cut the metal? All I've done is draw a rectangle. So what you want to do is click the Extrude button, which is right next to the Create Sketch button. When you click that, click the rectangle which you want to cut off, which in my case is the 8-hole piece. When you select it, there is an arrow which you can drag and cut. You want to drag it until you cannot see any more C-channel left in the red and blue blocks. Then just hit OK and you've cut your first C-channel on CAD. Now, to go back into the original state, as in not having and activated the C-channel, hover over the master file on the tree and click the circle next to it, just like when you activated the C-channel you just cut. Now, we want to join these 5 C-channels to create the shape of a basic base. To do this, it is very simple. As you can see on all the C-channels, there are black dots in the exact center of each holes, and these are graciously done by the people who made the library. To join these C-channels together, click the Join button under the Assembly section in the toolbar. Now, you can see why I orientated the C-channels like I did in the beginning. I just now have to hit Join and click the 35-hole C-channel on the hole I want to join, and then click the corresponding hole on the 27-hole C-channel. Remember that the first component that you click will move to the second component that you click. Now just repeat this for the rest of your C-channels. I also want to add another C-channel on the top, which is as well as 27 holes long. So all I have to do is select the 27-hole C-channel and copy and paste it underneath the master file in the tree. You can then drag these 2 files into your base metal component. You can then move the 27-hole C-channel to the top and then join one hole to another. Remember to select the 27-hole and then the 35-hole as you want to move the 27-hole C-channel. Now, I want to add bearing blocks. This is very simple, as you can go into the library and find the folder named bearings. Then just drag and drop this into your file. Then select the joint tool and select the side which you would usually screw onto, which would touch the C-channel. However, make sure that you are first clicking the first joint on the face. This will then show that the selected part is blue. Then you can go and select the hole that you want to join and then use the second joint and put it on the C-channel. Now just repeat this for all of your bearings. You do not have to add motors at this point, but I just thought I would. It is the same process like everything we've done before. Drag and drop the motor into your file and joint the motor to the bearing. Remember that you want to click the face like I do, and then select the center region. When I first CADed, this was a mistake I would make every single time. Just make sure you select the face and then the center point for all parts which do not already have sketches on them. Now just repeat the bearings and the motors for the right side. And don't forget to do put bearings on the outer C-channels. Now you may see that the bearings are inside the C-channels when I joint them. This is alright. All you need to do is click the flip button on the panel which pops up when you joint something. Now we can move on to spacers, which will then lead to gears and wheels. Like everything we've already done, select the face of the spacer, then the center dot, and just joint that to the black dots on the C-channel. Now I want to create a 257 RPM base, and to do this, I need to have a 36 tooth gear attached to the motor and an 84 tooth gear where the wheels will go. Select the spacers. When you drag in the gears, select the face and click on the center dot to joint it. Here, you can see I accidentally placed a spacer on the wrong hole. This is an easy fix. In your tree, you can see that there's a joints folder and an eye icon on the left-hand side. Click the eye icon so the eye is now visible and you can see all the joints that you make. Now, select the joint you made wrong and then when you edit the joint, select the axis which you want to change the joint on. Then select the arrow. Here, you do not want to drag it as dragging will not be precise enough. So since I know I have to move it just one hole to the left, I write negative 0.5 inches to move it one hole to the left. After this, I need to put some shaft collars on everywhere. It does not have to be in between the wheel and the gear, but since there is space, I decided to put it there. Now, like the gear, drag your wheel of choice, in which my case are 4-inch omnis and 4-inch traction wheels, which have been modified and are now dubbed by the VEX community the 169 traction wheel. This is a difficult component to make as it involves chain, but in a later video I'll show you how to make it. Now, you want to fill up the rest of the space with spacers, and in this version I do not add axles as I find them unnecessary and difficult to add. Now you can just repeat everything you did on the left hand side. When you're done, make sure you organize all of your parts in the folders, such as the base electronics and base motion, to make sure everything is easier to find in the case you need to edit something. This is all for this video, and next time we will go into the tower and arms of this robot. See you next time.